have to call it MOS, which stands for M something operating system. But now you know the story behind it. So why are we building this this tool? So if somebody's in the Bitcoin mining business or activity operations, one of the first things that you notice most likely is like there is never a tool that allows you to actually manage your whole site. So there are lots of single tools that are available, like the most famous one right now is Foreman, that can interact with your miners. But that one only tells you what the miner is doing. A Bitcoin mining site is much more than just a miner. You have the power coming in, it goes through transformation, it is then distributed to a series of systems, may that be in buildings or may it be in containers. Each container has its own distribution. Very often you have additional cooling systems, so if you're not doing air-cooled miners, you're using hydro-cooled or immersion-cooled miners. They have their own cooling system, and unless you're monitoring actually what the cooling system is doing, so how is the flow of water, how is the flow of oil, how many dry coolers are running to cooling down the system, you don't really know actually what is the efficiency of your site, because if you look only at the miner, you just know one part of it. And with Bitcoin mining becoming a more competitive business, which it is right now, being able to actually know exactly what is happening on your site is very important, because then you can understand where you have bigger losses, where you can improve, where you have issues. So that was the reason why we at Tether started developing MOS, Moria. And we had the big advantage that we're actually a tech software company. So we have a great team of software engineers that we could get together. And actually, it was when we went online with this tool, which was last year, basically from idea until the first product, which was actually running our operations, it took us 3 months, which was a ridiculously short amount of time. And I think there's some people here that were working on that. I think we had many sleepless nights. It was unhealthy, but it worked. And since then, of course, we're improving that and moving ahead with a more healthy pace. But it was quite a feat. And again, I think we could do that because of our company, because of our background, and the great leadership of Paolo Ardoino, who is himself ex-CTO, now CEO, who is actually was programming parts of these things. So that's what it does. Like the main point of MOS of Moria is that we can actually interact with all of the different devices that we have on the site. So what is the goal? We want to have an efficient and optimized management of our Bitcoin mining sites, and this tool allows us. We want to know how it's performing, so we want to have reportings, we want to have KPIs, and that's what this tool does as well. And we need to be able to, so when you're running a Bitcoin mining site, miners fail, you have to replace them. So it needs to also have that kind of dynamic aspect to it that you can actually change the miners, update the information of the miners. And more importantly, or most importantly actually for a Bitcoin mining site, is that you can monitor and manage the power consumption. So you know exactly how much you're consuming, you know exactly how much you are producing in hash rate, and you can use that for your KPIs. So I'm not going to get too much into the technical details of the tool itself from a development perspective, but you have all heard at this stage, I hope, about Hole Punch and Keat, which is a kind of a new architecture that Tether is working on through the company Hole Punch, which is one of our portfolio companies, that is basically using a similar architecture that Torrent was using. And I hope everybody here has used Torrent or is still using them, because as good Bitcoiners, you should. And Torrent basically allows two people to connect directly to each other and interact without going through a central server, so you could share files. And that Hole Punch, we have developed this, based on that architecture, a language that allows you to interact with each other peer-to-peer. So not only sharing files, but sharing data, streaming, chatting, talking. And also we use that as a basis of Moria. So we use Hole Punch peer-to-peer data structures. And part of the data stack of Hole Punch is already open source. And as Moria itself becomes more robust, we'll also start to open sourcing part of that as well. So this is just very briefly showing you how the architecture works. Again, I'm not going to enter too much into the details. But the interesting part about it is that it's extremely scalable. So we have workers for each device that can interact with an orchestrator that then gathers the data. And you can have many of these workers that are interacting with each type of device, or you can make it redundant as well, so you have better uptime or less issues. But let me talk to you more about the product itself. So regarding integrations, I mean, we can integrate with everything, really. Like that is what it's about. And so when you're thinking about integrating, for instance, with what are the pools, because we want to have the pool data integrated into our system, most of the pools now have very good APIs that allow you to interact and you can get the data that you need. And then you can also integrate directly with the power source. So either getting the power from the grid, in that case you're just like basically seeing what you're consuming from the grid, but you can integrate it with any proprietary power source. So in a lot of our sites we are building actually PV and wind and geothermal. We're going to talk about that actually tomorrow on main stage. And there you can basically integrate what you are producing and what you're consuming as well. And maybe just before I go that, like regarding integrations, maybe one of the challenges is that the reason why there are tools such as Format that interacts with different miners is that you have basically a limited number of devices, of miners that you need to have an interaction with. So in the market, you have like 3 suppliers, main suppliers of miners, and now there's a couple more coming in. But basically, Format has a set of APIs that interact with these miners. But if you're looking at a Bitcoin mining site, you just don't have just the miners. You have the cooling system. You have the power meters. You have the switch gears, and each one of them has their own type of communication, language of communication, protocol of communication. So actually, one of the reasons why it will be difficult for a small company to do something like that is that you actually need to interact with all of these. So either you're going to choose all of your devices to use the same protocol to make your job easier, or otherwise you need to have the expertise in-house to be able to actually integrate these kind of devices as well. Just to give you an idea of how the whole thing looks, like if you look at the dashboard, you have the most important information that you need for the mining operation. So you have basically a chart that shows you the last hours of the hash rate. And what we do is, of course, what is important for us is the hash rate of that we see from the miners and the hash rate that the pool is telling us that we're seeing. Because the hash rate that the pool is telling us that exists is the one that generates revenue for us. And by having them actually both next to each other, we can also notice or figure out if the pool is scamming us, let's say, or if there's a reason why we are seeing less hash rate from the pool than what we are seeing from our miners. So we interact with the miners, we interact with the pool, and we see, okay, how are these two things matching or not? Then we have the power. And you can see on top there, for instance, you see an efficiency number. And what is important is like this is not the efficiency, this is not the average efficiency of the miners. That's the actual efficiency of the site, which means that we look actually how much energy is the site using and how much hash rate it is producing, taken by the pool. And therefore, this is actually the number that you want to maximize. Because if you say, oh, I have great miners, they have great efficiency, and then you're losing energy left and right, or you're having too much of a cooling or other issues, then you're not going to see that. It has like an explorer that you can see all the different types of devices that are registered on the site. So these can be miners, these can be the cooling systems, they can be the cabinets, they can be the transformers. What we're also bringing into Moria is like what usually is called in traditional site a SCADA system, which is the monitoring system. So you can see also the flows of electricity. And then in this case, example of where we have like containerized solutions, you have like a single widget for each container. And this allows the operator, so you have to imagine you're running a site. The site has 20, 40, 50, in this case, containers. So this is the one that gives you an overview of what is happening on the side. Like the one before gives you like the overall, like just the main numbers. But then you also want to know, is there any issue in any of the containers? And in this screenshot, fortunately or unfortunately, there was no issue, but you would see it at the blink of an eye on this basically container widget page, where you see for each container, if you look at one of these boxes, basically you see the oil temperatures. In this case, it's an immersion cooling system. So you see the oil temperatures of the different tanks. You see what is the efficiency of that container. Again, efficiency of the container means what is that container consuming and how much hash rate is it producing. It's not the average efficiency of the miners. You see the maximum temperature of the miners to see if there's any issues, and you see the hash rate that it's producing. The bar at the bottom is actually quite important, I think, if you're managing a site, because it tells you from the whatever slots of miners that you have in that container, how many are offline and how many are empty. Because that's kind of, if you're a site manager, that's what you want to minimize. So you don't want to have any empty slots. It means you need to fix them faster or replace them faster. And here, those temperatures, basically, that you see that you're setting, like what is the temperature that you allow. Again, these ones will change the color. So in this case, you see 39. Let's say it goes to 42, it turns orange. It goes 45, it turns red. And then at some temperature, you have an alarm. And then you have the local alarm as well that basically just turns off the system. But this obviously allows you to prevent that. So you don't want to arrive to a situation where the local container management system is basically shutting down that operation. You want to see it here before, so you can intervene. And you can intervene in a bunch of ways. You can turn off some miners. You can go check what's happening, and so on. So it's really useful in order to increase our uptime. And yeah, and then not getting too much detail, but I think this is interesting, because if you then go into the details of a container operating page, so here you can see on top those the red bars and the tank 1 circulation, tank 2 circulation. Basically, what you can do there is like, that's how we start and that's how we stop the operation. So many operations need regular stops or starts, depending on kind of power contract you have. And that's how we can do it. And this is, of course, all things that can be automated in case you want to use it for curtailment or any other kind of automatic shutdown. And by the way, the case with the changing colors, you can see in this case where we have a bit elevated tank pressures, so they turned orange. You see also how many dry coolers are running. So it gives you just one more level of detail, right? So we started from the dashboard where you see the overall set, what it's doing. Then you have the widget of the container where you have the most important information. Then you go one step deeper and you have the container-specific information. You see how it's running. You see how many miners are on. You can turn it on. You can turn it off. You have a heat map of all the miners. So you can say, OK, show me the heat map of the inlet temperature. Show me the heat map of the hash rate temperature. Or show me the heat map of the chip temperature or hash rate. And you can see them. Again, you can see just visually in this case as well, if any miner is not doing well, that the hash rate is too low. Or another application is like, if you don't want to automate that, is like when you're close to the temperature limits, you go, like you look at the hash rate temperature or chip temperature and say, OK, like those 5 or 6 miners are the hottest ones. I'm going to turn those down, turn it off, or just lower their consumption. And therefore, again, making sure that they don't actually get damaged because of high temperatures. And again, these things are all things that can be automated. Yeah, and then if any alert you have based on severity, so how critical it is, and when it happened, what it's affecting, so you can intervene again, and you have flashlights on the dashboard and things like that. And then you have a bunch of tools and features that allow you to do the reporting on the site, because you don't want to just manage it, operate it. You also want to actually see how is the site doing. And for that, we can define any KPI we want. And we integrate that into what we call the reporting tool. So for instance, we can see, there on top how many miners are online versus how many miners are installed. Or I think I don't have a laser pointer here. Sorry. You see there on the top, on the left side, you see you have like 820 petahash per second. And that yellow number is what is actually the installed capacity of miners. So it's 800, what is it, 21, and we're at 819. So basically it shows you like how much are you below what you're supposed to be. And then of course you can also go above because you can overclock the miners and so on. And then we have the same thing about the power consumption, just showing, making sure that we're in the range, in what we need to be. About the efficiency, so same thing, you see like what is the average efficiency supposed to be, and where are we, how far are we from that. And we always, like everywhere where it makes sense, we compare, like for instance, the efficiency, because there's a hash rate, so we look at what is the hash rate that the miners are telling us, and what is the hash rate that the pool is telling us, because these two things are both important. And then, of course, we can have a look at the miner KPIs, so how many miners are broken, which type, which brands, or which models are broken, what is the average efficiency of per miner type, what is the average hash rate per miner type, historical data, and so on. So I think the bottom line is, and you can, of course, produce financial data, financial reporting, how much Bitcoin have you produced, how much did it cost you, and everything basically that is required for that. So everything you saw were actual screenshots from our actual product. And as mentioned, we are working on a lot of features that are upcoming. Probably the most important one is actually the inventory management tool, because I think when you have that, you have a complete tool like that. I would say like that is the one thing that is still missing that we're working on, because inventory, basically, the miners are like 80% of the capex of a site. So you want to make sure that everything is in order when it comes to miners being moved, being placed. You want to know exactly where is which miner at what time, what is the history of that miner. And we have that all as long as the miner is actually in operation. But once we take it out and take it to repair, it goes to another system as of now. So we're working on bringing that all in. And then a lot of automations, so automatic curtailment, automatic starting or a quick shutdown. And the thing with automation is always like, it's kind of a double-edged sword, because first of all, it can become a black box, so you might not know what it's doing. But the more important thing is like, we have a lot of operators on our site, and they have to actually operate this. And if you automate everything for them, they're not going to do anything anymore. And I'm not saying it because they should do something, but it's because they need to learn. So when you actually are operating the site, the more you're actually manually engaging with the site, the more you learn. And for us, we started Bitcoin mining, and I think 2 years ago, very small, from a very small site. Now I have a couple of exahash, and we're expanding rapidly. But for us, in the learning phase, you actually want to have more manual things, because that's how you learn, how things work. And then once you learn it, you can automate it. You can, in the next site, maybe run the site with less staff, higher uptime. So that's our approach, at least. Yeah, so I think that's actually it. Sorry, it was a bit technical. So I think if somebody here is a miner, I think they appreciated it. If they're not a miner, maybe they were a bit bored. But thank you very much for your time and the interest. And I'm here for questions as well.
Does anyone have any questions for Giw? Oh, we got, all right, here you go.
How intermittent can the mining be? You talk a lot about like grid services to support, like providing primary reserve or secondary reserve or balancing. I mean, can you ramp it up and what time you need it? Or does it have to have a minimum base load? I mean, the mining, and you already take into account like 15-minute prices for electricity when optimizing the operations of your mining site.
Yeah. No, Bitcoin mining is very flexible. So you can do the shutdown immediately, like batteries, basically just shut it down. The startup, usually it ramps up from 0 to nominal consumption in about a minute. And then if you look at reserve markets, because basically you want to see what kind of services can you provide to the grid, often you have, in the more developed market, Europe and US, you have the primary reserve, secondary reserve, tertiary reserve, and that one decides basically what is your reaction time. So basically with the shutdown, you can always participate to the negative primary reserve, and then you can always participate to the secondary positive reserve as well. because you can ramp up. Usually they ask a 5-minute ramp up to nominal consumption. So yeah, those are more or less the edge cases.
So we had another question over there, right? There we go.
Yeah, that was an awesome presentation. We're miners as well. What we do is we aggregate the total kilowatt hours from our utility bill at the end of the month and aggregate the total hash rate out of a facility. My question, so I'm very much understanding of what you're doing here. It's great. When you have different types of machines like microBTs and Bitmains and different generations, as you know, the tool sets and just the API calls evolve over generations of machines. How do you work around that? Like as a software, they can interact with older S-series Bitmains and newer ones and microBTs all in the same facility?
Yes, yes. So basically, we have the APIs of all the machines that we have on the site, and we have those APIs defined, and we can interact with them. Yeah. And if we add a new type of device to the site, we first test in our lab the API and the compatibility, or even if there's a firmware update, we don't do blind firmware updates. We test in our lab that the firmware update is not screwing up with our APIs. And then when they did those checks, we give the green light to the site to do updates.
Nice. And then one other question is just when you compare the pool hash rate and the reported hash rate, you're just getting the APIs from the ASICs and comparing what the pool's reporting back to look at the delta.
If you get the delta?
To look at the delta, you're just getting the miner reported hash rate for the API compared to what the pool's reporting back. And that's what you're exhibiting there.
Exactly.
Yeah, nice.
Frank Holmes here. You said you've been mining only for a couple of years, and I'm really impressed. You're in Uruguay
as
also?
Well. Yes.
And we're going into Paraguay. We're building out now 100 megawatts. So it's interesting to see the dynamics that are taking place in that region.
Oh yeah, absolutely. Yes, I agree. I mean, for sure if you're looking at 100 megawatt. Bitcoin mining is, I think, ultimately quite political as well. So it's often political decisions that make or break a deal, either on the legislative side. So, okay, is a country deciding to let in miners and is it giving them conditions that are good? And then usually they go ahead and change those conditions, as we have seen many times.
Your green energy, correct?
Yes, yes.
Same here.
Yeah. Yeah. I mean, there's so much green energy around. I mean, for us, lots of things are green. Like hydro is green. Some people say hydro is not green, which I think is ridiculous. But yeah, there is an abundance of wind, solar, hydro, geothermal in the world. So and they don't have any marginal cost because you don't have fuel costs. So in the long term, they're actually quite competitive.
Well, Amazon has now made nuclear green.
Yes. Well, nuclear is also green. Definitely, I believe so. But sometimes it's a matter of definition. Like the World Bank is not giving any more loans to African countries to build hydro because they say it's environmentally unfriendly. It's like, it's subjective.
All right, does anyone have any more questions for Giw? Going once. Oh, we got a question over there. Great, because I would have had to hold down the stage for 5 minutes.
Thank you for the presentation. Just a question about Northern Data. I know that Tether subsidized like $500 million for Northern Data. I just wanted to know if you have a relationship with this company or how it goes with this company.
Yeah,
Northern
we are
Data.
investor. I think it's public knowledge that we have invested into Northern Data.
Okay. No, but just wanted to know if you work, like if the site you were talking about were from their side or it's something that you have by your side.
We have our own proprietary sites, and then we have investments in other companies that run sites.
All right, any more questions? Any more questions? Going once? Going twice? Going twice again? Oh, we got one more question in the back. Sweet.
I mean, in a technical side, are you afraid there is like a skill switch on some ASICs like there was a few years ago?
Yeah, I think it's very likely. I think it's not likely, but it's possible for sure. I mean, I'm not so much on a kill switch. I think there might be a way to... I think there's a possibility that the efficiency of the miners could be better. sometimes, and is not in the open market. But it's a good question. I'm not sure if there's. We have to think about incentives, right? So why would you want to kill switch? I mean, if you want to like kill the competition, if you're competing against somebody with your own miners, then you want to have a kill switch so you can kill the other miners. I would say the possibility is not zero, I think, yeah. But I wouldn't know. Just speculation.
Any more questions for Giw? Going once, going twice, going 3 times. All right, ladies and gentlemen, please, another round of applause for Giw.
Thank you.